Hello, my lovely students. How are you all doing? I can see the chat here. So Tanushri and Vignesh are chatting. Yeah. Hi. Live inkapudu start avutundi. Yeah. It just started. Hi everyone. Hi. Welcome to the class. How are you all? How was your Sunday yesterday? Yes. How was your Sunday yesterday? How is your studies going on? For some of you, the final exam is on April 6th, right? For Vignesh, I don't know, for Tanushri. Vignesh, in which standard you are studying in? Where are you from? Everybody is talking in Telugu now. Book phone pattukuni kurchunnaru. Okay, you're holding the book and sitting. Okay, that's nice. Yes. Yeah. Yeah, I do understand Tanushree. Kannada and Telugu are very similar. I understand Telugu. Kannada and Telugu is very similar actually. The vocabulary that you and we use are quite similar. Oh, you're in 8th class, Vignesh. That's really nice. That's why you were calling Tanushree Akka. Cool. Welcome to the class, all of you. I'm Ankita BL. You already know me. I'm the chemistry master teacher. Welcome to Diksha Vedantu English channel for 9th and 10th. And we are going to discuss the part 2 of structure of atom. So this is a foundation class, guys. This is not your CBSE or state board class. This is a foundation class. Okay, for NTSE, for NEET exam, for JEE exam, Olympiad exams. This is the foundation. This is like a bridge course. Okay. Oh, Vignesh is your junior. That's very nice. I'm glad that you are sharing the videos, the channel with your friends. This is really good. Yeah, we can reach to more people, more students, and they get they get the benefits. Yes, let me already tell you, in the part 1 we have discussed, as Tanushi was saying the same thing in the last class as well. In part 1 we have discussed the CBSE part of the syllabus. Part 2 is about the extra extra topics, extra concepts that we will be having in your higher grades. Alright. Yes, in part 2 we have discussed just the CBSE part of the syllabus. CBSE or your state board. In today's class, in part 2 we are going to discuss higher level concepts. Okay. Yes, this is not going to come to your final exam or in your board exam or anything. Okay, so this is for your competitive exams, and it is the foundation or basics for your grade 11 and grade 12 if you're writing NEET, JEE or any competitive exams like NSTSE and NTSE. Let's get started then. Let me remind you to subscribe to the channel. Please do subscribe to Diksha Vedantu English for 9th and 10th. And yes, we are conducting foundation course. All of us are conducting foundation course. Neha ma'am, Navya ma'am, Suhas sir, me. And 28th, 29th we discussed matter in our surrounding. 30th and 1st, that's today. Today is April Fool's Day, right? Yeah. And yeah, we are discussing part 2 of the structure of atom. Tomorrow and day after tomorrow is matter around us pure, and 4th and 5th of this week we'll discuss atoms and molecules. Okay. Is this topic no, this is not there in your 10th grade, Tanu. No, this is not there in your 10th grade. Okay, this comes in grade 11 again. Grade 11. Okay, grade 11. Yes. Tanushri, which class? Hi Siddharth. Tanushri is in 9th grade. Siddharth, she is writing exam on April 6th, from April 6th. Yeah, so let's recap what we have learnt in the previous session. We have discussed about subatomic particles, not to forget. We have discussed about subatomic particles, electrons, protons and neutrons, and Thomson's model of an atom. So we have discussed about Thomson's model of an atom. An atom consists of sphere of positive charge with negatively charged electrons embedded in it. Okay. And yes, an atom is electrically neutral because negative and positive charges are equal in magnitude. Okay, so this is about Thomson's model of an atom. What is it called? It has 2 other names. What is it? Tell me the answer. Come on, here, come here. Back to the class. Yes, very good. Watermelon model of an atom. Very good. So this is also called Thomson's plum pudding or watermelon model. Okay, watermelon model or plum pudding model. Plum pudding model of an atom. Okay, there are there are some disadvantages or limitations. Next, the limitations were overcome by Rutherford's model of an atom. A lot of empty space is present inside an atom. He proves that. What is this experiment? Alpha scattering experiment. It's called alpha scattering experiment or gold foil experiment. Both are same. Okay, alpha scattering experiment or gold foil experiment. This also led to the discovery of neutrons. Okay, not only did he come up with the model of an atom, but it also gave us the discovery of neutrons. Alpha scattering experiment or gold foil experiment. So what is the, you have chosen PCM. Ah, you have not started yet. Okay. Rutherford atom. Even Rutherford model of an atom had some limitations. You're absolutely right. Okay, you have chosen PCM. Okay, good choice of subjects. Very good. Yeah, a lot of empty space is present in an atom. This is actually true. Okay, there are a lot of space that is present. Empty space is present inside an atom, and there is a center of positive charge in an atom which occupies very little space. Okay, he also discovered the. He also estimated the circumference of the nucleus and the size of the atom. Okay, so it is almost 10 raised to 5 times the atom is 10 raised to 5 times bigger than that of the size of the nucleus, and all positive charge and mass of atom is concentrated in a very small volume within the atom. Consider yourself standing in a football field. The football will be the size of the nucleus and the court, football field, will be the size of the atom. That's how the comparison can be made out. So conclusion, Rutherford's alpha scattering experiment shows the presence of nucleus in the atom. This is the this is the positive side or the discovery of Rutherford model of an atom. But what is the disadvantage of Rutherford model of an atom? It could not explain the it could not explain the stability of an atom. Okay, because whenever there is a charged particle, when it undergoes acceleration, it would lose energy. When it loses energy, it would eventually fall into the nucleus, which makes an atom very unstable. Nothing would exist if Rutherford's model of an atom was true. Okay. Rutherford model, not everything is wrong, Siddharth, but few things are there are drawbacks for this. Okay. You'll study from September. Okay. MPC. You'll also choose PCM. Okay, that's nice. No. It's okay to have dreams. No problem. You don't have to be ashamed of expressing what you dream about. Okay, it's okay. So I saw something about UPSC, right? You have a long way to go, I would say. But whatever you're studying now, study it properly and do not forget it. People have this tendency to write the exam and forget whatever they have studied in the class. Okay, don't do it. So just keep on remembering things and revise things. And for UPSC, I would say social science is extremely important. History, geography, all those things. Okay, chemistry, physics, only if you choose the that paper, it would be important. Otherwise, general knowledge is very, very important. Current affairs and general knowledge. Okay. Yeah, absolutely. Okay. Hi, Hero. Welcome to the class. Tanushree, is it okay to prepare for UPSC exam after doing a software for 2 years or something else? Software, as in you need a degree, Tanushree, in order to write UPSC exam. Okay. You need a degree. I don't think there is any degree for 2 years. Any degree would be of 3 years. Even it's BA, BSc, or what else, BBA, BBM, everything is for 3 years. Okay, ma'am, what is NTSE exam? Okay, Hema, NTSE exam is a competitive exam that is conducted by the government of India. Okay, I think it's by NCRT. Okay, they conduct these exam, and the students who qualify NTSE, they get scholarships. They have they get the colleges consider these competitive exams marks. Okay, they'll have a great what is it, scholarship programs. All right. Hero Tanu is still in 9th standard. I don't think she's preparing, but yeah. So moving forward, we'll discuss about dual nature of particle. This is not there in your syllabus, guys. Let me tell you again and again, my dear students. For CBSE grade, CBSE 9th grade, if you stick to the syllabus, these things are not there for your syllabus. This is only for grade 11. And for NEET exam, JEE exam, if you're writing JEE NEET exam, or if you're in 10th standard and you have passed out from 10th standard, or if you're writing any competitive exams, this is there. Otherwise, this is not there. Okay, do not unnecessarily just focus on these things if you have board exams or final exams. Cool. Hi Manish, very good evening, very good evening. It's your second competitive exam. Okay, that's very nice. So let's get started then. Dual nature of particle, Heisenberg's uncertainty principle, and quantum mechanical model of atom. We'll discuss these things. First, so developments of new atomic model. We have studied about Bohr-Bury scheme, or Bohr's atomic model. Right? It talks about the energy levels, discrete energy levels will be there, and the electron is going to lose or gain energy only if it jumps from a higher energy level to a lower energy level, or vice versa. So to overcome the drawback of Rutherford's model of atom, Niels Bohr proposed a new model of atom using theories we just studied. This new model is called Bohr's model of atom. Let's quickly revise significance of Bohr's atomic model today. Okay, so Bohr's atomic model worked well for spectra of hydrogen and hydrogen-like species, which means that whichever species or whichever element or atom has only one electron, the Bohr's model worked for it. But for others, it didn't. It could not explain. But even after Bohr's model of atoms suffers from following limitations, which is that inability to explain line spectra of multi-electron species. Okay, you'll study something about line spectra. Okay, so it could not explain that, and inability to explain splitting of lines in the magnetic field. It's called Zeeman effect. Okay, and inability to explain de Broglie concept of dual nature of matter. So what is this dual nature of matter? We'll discuss that. And Heisenberg uncertainty principle. What is this? We'll discuss about that as well. Okay. Alright. Yes, you must have heard about quantum physics. Okay, in physics there is a separate branch called quantum physics. Just like that, even in chemistry we have quantum chemistry. Okay, so yeah, the development of a new model was mainly based on following two concepts: de Broglie concept of dual nature of matter particle, and Heisenberg uncertainty principle. So dual nature of particle. In 1924, de Broglie, he is a scientist, proposed that an electron behaves as a material particle and as a wave. It has dual nature. It acts like a wave. Okay, and it acts as a material particle. The wavelength associated with a particle of mass m moving with velocity v is given by the relation, this one, lambda is equal to h by mv. H is a constant. Okay, h is a constant. So for microscopic particles, we have studied about h in the last class. That's Planck's constant. Okay, so this is obtained by a derivation which you will be studying in your higher grades. Okay, what's my qualification? I have done my MSc in general chemistry. Yeah, I have done my MSc in general chemistry. Hero, thank you, but yeah, I don't have a PhD. for macroscopic particles with higher mass. Microscopic means very very small particles. Macroscopic means considerably bigger in size. Like cricket ball, wavelength is very small and undetectable. So relationship between de Broglie wavelength and kinetic energy of electron. So nu is equal to h by p. Okay, nu is equal to h by p. So p is equal to root of 2m into Ke. Ke is kinetic energy, m is the mass. Okay. Yeah. We'll do that, Tanushree. Okay. We'll start a separate reel for that. I mean YouTube shorts for that. Cool. Yeah. My Telegram. I'll check it right away. Okay, because I almost forgot about that. Just give me a second. Yes, moving forward, give me the answer for this one. Using this equation, calculate this. The de Broglie wavelength of a car of mass 1000 kg and velocity 36 km per hour is dash. They have given in kilometer. You have to convert it to meter. Okay. Try to do this. Okay. It's Ankita Hegde. It's Ankita Hegde. Tanu. H by mv. H is Planck's constant. It's always constant. It's never going to change. Okay, mass is already given 1000 kg. So H Planck's constant is 6.626 into 10 raised to minus 34 joule per second. So whenever you are doing any calculations, okay, you have to be very mindful of the units that they give. Okay, V is equal to 36 km per hour. So 36 km per hour. But the answers are all in meters. Okay, so we are never going to calculate in hour, rather we are going to calculate in seconds. That's why you have to convert it. 1 hour, so 1 hour means how many seconds? 60 into 60. Okay, so 36 into 10 raised to 3. Why 10 raised to 3? 1 kilometer is equal to 10 raised to 3 meters. That's why 10 raised to 3 meters, that is 1000 meter. This is how you convert things, convert units. Okay, so what will be the answer? 10 meter per second. So V is known now, velocity is known. Okay, so so lambda is the wavelength. So lambda is the wavelength. So we can calculate that, just simplifying everything. 6.626 into 10 raised to minus 34 divided by 10 raised to 3 into 10. Okay, m into V. So what is m? That is 1000 kg. Okay, 1000 kg, which means that 10 raised to 3 into 10. So final answer will be 6.626 into 10 raised to minus 38 meter. Okay, understood? Yeah, I'm from Karnataka. I'm from Karnataka. I'm from district Shimoga. Moving on, the drawbacks of Bohr's model are that it did not explain the Zeeman effect and Stark effect, stability of an atom, spectrum of hydrogen-like species, explain the Heisenberg's uncertainty. Stability of an atom, it could explain the stability of atom, right? Yes, it could. Spectrum of hydrogen-like species, absolutely. It could explain both of this. But what about Zeeman effect and Stark effect, Heisenberg and uncertainty principle? Spelling of what exactly, Tanu? My ID, it is Ankita BL. No, sorry, Ankita Hegde. It is both, it's also called Shimoga or Shivamoga. Both are right, Manish. What is the answer? Option B, 1 and 4. It could not explain Zeeman effect and Stark effect, as well as explain Heisenberg uncertainty principle. Okay, it could not explain that. See, we have studied that already. Let me show you here. See, inability to explain splitting of lines in the magnetic field and in electric field. So splitting of lines in magnetic field is called Zeeman effect. In splitting of lines in electric field is called Stark effect. It could not explain that. And de Broglie concept, it could not explain. Heisenberg and uncertainty principle, it could not. Okay. Hero, I know you do. You have an Instagram account. I know that. It is something called Midnight Thoughts. I know that. Oh, that is very nice, Manish. NIT Surathkal is one of the most prestigious colleges in Karnataka. Very good. You should follow his footsteps if you're interested. Hmm. So next, the de Broglie wavelength of a tennis ball of mass 60 grams moving with a velocity of 10 meters per second is approximately dash. Yes, the de Broglie wavelength of a tennis ball of mass 60 grams moving with a velocity of 10 meters per second is approximately dash. Pratyush, we wanted to take classes, but the response was not that great. That's why the response here in this channel is very good. That's why we are taking foundation classes here. You can follow the series that we have conducted in this channel as well, because for science the syllabus is almost same, and in that channel also we have conducted most of the most of the concepts are covered there. We have done top 50 questions, we have done top most asked questions, all of those things. Okay, is it option C? It is option D. How do we do that? Lambda is equal to h by nu. H is a constant. Okay, so there they have given already the mass. Mass is 60 grams. Okay, m is 60 grams and velocity v is 10 meters per second. Okay, 10 meters per second. So it is going to be 10 raised to minus 33 meters. Just simplify it. Okay. Yeah, Tanushi, I do have Insta. Yeah, moving on, Heisenberg uncertainty principle. Okay, so what is this Heisenberg uncertainty principle? Okay, so it is ruling down that using the equations of classical physics, we can calculate the ball's position, direction of motion and speed at any instant with great accuracy. Can we do the same for an electron? We can calculate all these things, direction of motion and ball's position and speed, discrete energy levels, right? Can we do the same thing for electrons? What do you think? On Telegram, it's Ankita Hegde, both. Yeah. Both Ankita Hegde. Okay. Yeah. So let's concentrate on the subject now. Okay. Heisenberg uncertainty principle. So the answer is no. A wave extends in space and its location is not precisely defined. So around the nucleus where the electron is revolving is not precisely defined. Thus, it is impossible to determine exactly where an electron is located at a specific instant. For example, I'll show you here. This is the nucleus of an atom. This is the nucleus of an atom. Okay. So, electron could be here or electron could be here, or at some point electron could be here. Okay, so the location is not precisely defined. This is what exactly was told by Heisenberg. Okay, Heisenberg told that the location is not precisely defined for electrons. Okay, Werner Heisenberg in the year 1927 stated uncertainty principle. What did he say? It is impossible to determine simultaneously the exact position and exact momentum of an electron, either one of which can be calculated or found out, but not the both at the exact simultaneously we cannot find both of this. Okay, exact position and exact momentum. Okay, yeah, I saw that, Pratyush. I'm not from Mangaluru, but I am from Shimoga. Hi Thor, hello. So Heisenberg uncertainty principle. So if delta x is the uncertainty in position of the particle and delta p is the uncertainty in momentum of the particle. So what does it say? Delta x into delta p is greater than or equal to h by 4 pi. Okay, so h by 4 pi. We have Planck's constant there. What is the value of pi? Yes, what is the value of pi? Have you heard about pi? Yes. Pi value is 3.141. Okay, so take this down. Pi's value is 3.141. Hi Gokul, can you teach in Kannada? Okay, I can teach in Kannada, but this is an English channel, so we have to stick to English. But in Kannada channel, we teach in Kannada. You can check that out, Gokul. Okay, Kannada channel saha ide namdu Diksha Vedantu Kannada for 9th and 10th anta. So alli neevu hogi check ಮಾಡಬಹುದು. We have uploaded a lot of videos. We have taken lives as well. Okay, 22/7. Very good, very good. Yes, 3.141. Absolutely right. Very good. Keep it up. Yes, Skanda. Hi Skanda. Long time no see. Welcome to the class. Yes. So what is the significance of Heisenberg uncertainty principle? It rules out existence of definite paths or trajectories of electrons and other similar particles. So what does it say? The Bohr's atomic model says that so electrons are revolving around the nucleus in discrete orbits, which means that there is a definite path. Okay, but this is not the case. It is not precisely found. Okay, since we can't talk with certainty about the position and velocity of electrons simultaneously, we can only talk about the probability of finding electron. So what do you mean by probability of finding electron? Okay, so electron might be somewhere here or electron might be somewhere here. That is a probability. We don't know for sure where the electron is exactly located. Okay, so this is what happens in the quantum mechanical model of an atom. Alright, moving forward, if uncertainty in the position of an electron is 0, the uncertainty in its momentum would be dash. There is uncertainty in position of an electron. Okay, that is equal to 0. The uncertainty in its momentum, so we have, yeah, see here, delta x into delta p will be greater than or equal to h by 4 pi. So what they have said, delta x is equal to 0. So what about delta p then, if delta x is equal to 0? Tanushri, no, my birthday is on October 31st. I'm doing great, Skanda. Thank you for asking. How are you? How is it going with you? You just finished 10th grade, right? How did the board exams go? And how are you enjoying your summer holidays? The summer is scorching hot this year. I'm not able to tolerate Bengalore's weather. I don't know so how people are tolerating the heat from other parts of Karnataka or India. Yeah, it is infinite. Okay, so delta x into delta p is greater than or equal to h by 4 pi. So if delta x is equal to 0, then delta p is equal to infinity. Okay, it's infinite. Next, so this came in JEE Mains 2002. How long was that? Oh, 22 years ago. Sorry, yes, is it 22? No, 12 years ago. Yeah. Now tell me the answer. It's 22 years, yes. Ah, this is nice. Board exams went good. Super hot in Bangalore. Yeah, I know, right? This is really hot. Even Bangalore people are, people we are complaining, and I don't know about others. And Diksha Bridge course is going on. Okay, that's very nice. How is it? Did you meet Tarun? Option D is the right answer. Calculate it. It's very simple. See, delta x is into delta p is equal to h by 4 pi. What they have given here, h we already know, pi, the value of pi we already know. right? So uncertainty in position of mixture particles of mass is 25 grams. Where are we going to keep that? H we already know. Okay, what is the uncertainty? In its velocity they are asking. So delta V is equal to 6.6 into 10 raised to minus 34, okay, divided by 4 into 3.14 into 0.025 into 10 raised to minus 5, which is equal to 2.1 into 10 raised to minus 28 meter per second. Hi Tarun, you're saying hi to Skanda, no hi to me. Hi. Yeah. So this is the answer. Next, Heisenberg uncertainty principle is applicable to dash atoms only, electron only, nucleus only, any moving object. What is the answer? It is option D, any moving object. Heisenberg uncertainty principle is applicable to any moving object, which means that we cannot be simultaneously calculating what? We cannot simultaneously calculate exact position and exact momentum of the moving object. Okay, it could be anything. Alright, option yes, D is the right answer. Very good, Skanda. Yes, Vignesh it is. Very good. Vignesh, I highly doubt that you are in 8th grade. You have been answering really well. Keep it up. Next, uncertainty in the position of an electron with mass equal to 9.1 into 10 raised to minus 31 kg. Moving with a velocity 300 meter per second, accurate up to 0.001% will be dash. Substitute and give me the answer. See, given m is equal to 9.1 into 10 raised to minus 31 kg. Okay. Next, h, we already know that. Velocity is given. Okay. Meter per second. So, accuracy is also given. So, 300 into 0.001 divided by 100. Why? Percentage is given. That's why. So, delta V will be 0.003 meter per second. Delta X is equal to 6.63 into 10 raised to minus 34 divided by 4 into 4 pi is there, right? So 4 into 3.14 value of pi, and delta V, it is in the denominator now, delta X into delta V. So it is in denominator now. Okay. Yes, rearranging it. And 9.1 into 10 raised to minus 31. What is it? It is the mass of the electron. It will be equal to 1.92 into 10 raised to minus 2 meter. Conversions are very important here. Okay. Next, quantum mechanical model of atom. So, quantum mechanical model of atom. So, Bohr's model of an atom, dual nature of particle, and uncertainty principle. The gist of all these things were taken. Okay. So, Erwin Schrödinger developed a model which is based on the particle and wave nature of electron, known as quantum mechanical model of an atom. So, in the year 1926, he is Erwin Schrödinger. Yes, this model describes the electron is a three-dimensional wave in the electronic field of positively charged nucleus. So, we know that the nucleus is positively charged because of protons. Okay, protons are there, neutrons are also there, but protons are positively charged, neutrons are neutral in nature. Because of the presence of protons, the nucleus is a positively charged mass. Okay. So, electron, it explains that electron is a three-dimensional wave. Okay, the nucleus is going to attract the electron. It holds on to the electron. Okay, the fundamental equation of quantum mechanics was developed by Schrödinger. Okay, for a system, such as an atom or a molecule whose energy does not change with time. So usually, what happens? The energy of the system wouldn't change for an atom or a molecule, a stable atom or a molecule. Okay, so it could explain the it could explain the fundamental equation. So the equation is this. Okay, so this is called Schrodinger equation. So H is a mathematical operator called Hamiltonian, which can be constructed from the expression for the total energy of the system. This symbol is the wave function, in which all dynamical information about the system is contained. E is the energy. Okay, so E is the energy. So this is nothing but Schrodinger's wave equation. You will be learning about that in your higher grades in detail. Okay, as of now, this is just a heads up. This is just a heads up. Okay, just give me a second. Are you there? So moving on, on solving this Schrodinger wave equation, so we get energy. Okay, it gives information about possible energy levels of the electron and corresponding wave function of the electron associated with each energy level. So we have K, L, M, N energy levels, right? So upon solving Schrodinger wave equation, we get the information about the energy as well as the corresponding wave function of the respective electron. Okay. I'll do that later, Tanushri. Mine is a public account, so you don't have to send any request. All right, this is it. This is my account. Okay? Yeah. Moving on, the model which describes the electron as a three-dimensional wave in the electronic field of positively charged nucleus is dash, which is our quantum mechanical model, Heisenberg uncertainty principle. The symbol represents what? Is it B option? For the previous one it is A option. Okay. Is it option? Yeah, for this question, it's option B, wave function. Absolutely right. Absolutely right. Yes. Moving on, quantum mechanics consider dash character of electron. Wave, particle, dual nature, none. What is the answer? This is psi. Okay, psi. Just like we have beta, gamma symbols, this is psi. P is silent. Okay, is it option B? It's option C, dual character. Okay, quantum mechanics consider dual character of electron. Next, let's summarize whatever we have discussed until now. The development of new model was mainly based on following two concepts: dual nature of particle, okay, and Heisenberg uncertainty principle. So nu is equal to h by mv, and Heisenberg uncertainty principles is nothing but it says that it is impossible to determine position and exact momentum or velocity of an electron simultaneously. Either one of them can be found out at a point, okay, not both of them. So delta x into delta p will be greater than or equal to h by 4 pi. Okay. So quantum mechanical model describes the electron as a three-dimensional wave in the electronic field of positively charged nucleus. Okay, h psi is equal to e psi. Next, we'll discuss orbitals, quantum numbers, Orbitals or orbitals, both of them are correct. Pauli's exclusion principle, Aufbau's principle, and Hund's rule. Okay, or Hund's rule. Yes, we'll discuss that. Before that, we'll take 5 minutes break now. Okay, let's take 5 minutes break. Alright, I'm back. So let's discuss about orbitals. So the space around the nucleus where probability of finding an electron is maximum is termed as orbital. Okay, so there is a probability of finding the electron. Electron could be, so this is the nucleus, electron could be here, electron could be here, or electron could be here. Okay, so this is the probability. So these are nothing but orbitals. So orbitals are like electron clouds and they do not have sharp boundaries. They do not have sharp boundaries. Okay, so s orbital is spherical. Okay, there are different kinds of orbitals. P orbital is dumbbell shaped. Okay, and d orbital is double shaped. And yes, let's discuss shape of s orbital. Spherical in shape, and the probability of finding the electron at a given distance is equal in all directions because it is spherical in shape. So from the center to any point on the circle will be equal. So energy and size of orbital increases with value of n. So n is equal to 1 for k shell, right? For k shell. So as the value of n increases, the energy and size of this orbital increases. Okay. Next one, dumbbell in shape, which is at p orbital. So dumbbell, it is dumbbell in shape, and there are two loops on either side of the plane passing through the nucleus. Okay, the probability of finding the electron like this, dumbbell shaped. Okay, and yes, through the nucleus having probability of finding the electron as 0 on it. There are two loops on either side of the plane passing through the nucleus. This is the nucleus and this is the plane. Okay, so this is the nucleus, this is the plane. All right, so what's happening here? Hi Krishna, hello. Yeah, there are two lobes on either side of the plane passing through the nucleus having probability of finding the electron as 0 on it. All three orbital have same shapes and energy. Okay, they have same shape and energy. Next we have d orbital. So double shape. This is double shape in nature, and all 5 orbital have equal energy. So there is this plane, okay, here and here. So we call 5 in total. Double, okay, 1, 2, 3, 4, and there is this one. Okay, so all 5 orbital have equal energy. So I discussed about s orbital, p and d, and there is f also. All right. Yes. Moving on, the region of space where there is maximum probability of finding an electron at any instance is dash. What is the answer? The region of space where there is maximum probability of finding an electron, that is orbital. Okay. Next, in which orbital the probability of finding the electron at given distance is equal in all directions? P orbital, d orbital, s orbital, none of these. Which is spherical in shape? Orbit is different, orbital is different. We'll discuss about orbit and orbital. Okay. It is s orbital. Okay. The probability of finding the electron at given distance is equal in all directions. That is s orbital because it is circular in nature, spherical in nature. Next, moving on to quantum numbers. What information do you need if you want to go to your friend's place? We need to know the number of the house number or area or cross, right? We need an address basically. So quantum numbers are similar to postal address of any any particular house. So they tell us the address of the electron, where electron is located. It is given by quantum numbers. Okay, thank you Tanushree. Yes. Quantum numbers can be defined as a set of 4 numbers with the help of which we can get complete information about the electrons in an atom. That is, location can be known if you know the quantum number, energy, type of orbital, shape, as well as orientation of that orbital. The various quantum numbers are principal quantum number, we have azimuthal or angular quantum number, magnetic quantum number and spin quantum number. So we represent all these quantum numbers using particular letter. For principal quantum number, we make use of the letter n, small n. Next, azimuthal or angular quantum number, small l. Magnetic quantum number m, or we mention ml as well. Okay, and then spin quantum number, we make use of s or ms. Okay, ML for magnetic quantum number, MS for spin quantum number. Okay. Moving on to principal quantum number. This represent the shell in which the electron resides. Shell is also called orbit. The energy levels KLMN or N is equal to 1, 2, 3, 4 respectively. That is the shell. It is also called the orbit. Okay. Orbit is different. Orbital is different. Okay. So orbital is the space where the probability of finding the electron is more. That is orbital or orbital. Orbit is the definite shell. Okay. So it can have any positive integral value except 0. It can never be 0 because K is the nearest shell to the nucleus, nearest orbit to the nucleus, and its value is 1. Okay. N is equal to 1. Principal quantum number. It can never be 0. Next, it gives us the average distance of the electron from the nucleus. Okay. So if it is in K shell, it is nearest to the nucleus. If it is in L shell, that is, if the principal quantum number is 2, then it is in L shell. Okay. With increase in principal quantum number, size of the orbit increases or the electron will be located away from the nucleus. This is kind of, example of period. With the example of period, I don't understand. With a period as in the periodic table. Okay. If we take the example of sodium. Okay. Sodium has 11 electrons. Right? Oh, in order to explain this using, principal quantum number and everything, we need to know how to write the electronic configuration. Okay, we need to study everything and then we can explain using explain this for respective elements. Okay, otherwise we can't. Understood? Yeah, we'll discuss all these things and we'll go on with the example. Okay. Tarun, you don't have this in your CBSE grade or for your state syllabus. This is a foundation course. This is a foundation course. Okay. So this is something that will appear in your 11th. In 11th grade, you have structure of atom, right? You will be studying that in 11th grade. This in 11th grade, as well as in foundation classes. Okay. In part 1, we have discussed just for the for the board, as in your final exams, which is strictly for 9th graders. Okay. So part 2 of this chapter has more information. Has higher level concepts. Cool. Tanushi, that's not possible actually. Okay, that's not possible. So you'll understand when you learn about the quantum numbers and how to write electronic configuration, how to write orbits and everything. Okay, don't worry about that now. So that's not going to happen. Do you have, yes, you have classification of elements in 11th standard. Yes, periodicity, periodic properties, everything is there. Okay, there are only 118 elements in the elements discovered so far, Tanu. Okay, so that's why it's not possible. Tarun Suhas sir has already gone home. He took the class and he went. Moving on, azimuthal quantum number. Each value of L represent a different subshell. Okay, in shells we have subshells, guys. So while we were discussing, in the 9th standard, the teachers must have told you, or we have, we have told you about the, subshells. Okay, you must have wondered while you were discussing 2n square. So what if n is equal to 4? 4 square. 16 into 2, 32. How an orbit is going to accommodate 32? Because in Bohr-Bury scheme, they say that the maximum number of electrons that can be accommodated in an energy level is 8. Right? But in these orbits or shells, we have subshells. Okay. Is it necessary to memorize the noble gas and metalloid atomic number? Gokul, I would say yes for noble gases. Noble gases are extremely important and you need to know the atomic number of noble gases. Okay, but metalloids not necessarily, but for grade 11 and 12, you should know most of the elements because you have D and F block elements in grade 12. Okay, if you are writing competitive exams, this is very, very important. Even if it is CET, NEET, JEE, you need to know most of the elements in the periodic table for state board students. So depending upon the value of 0. Okay, so how do we do that? L is equal to n minus 1. Okay, for K shell, n is equal to 1. So how many L will be there? 0. 0 subshells are there. Okay, designation of the subshell is yes. Subshell notation will be 1s. Only one subshell will be there. That is 1s. If n is equal to 2, n minus 1, L is equal to n minus 1, that is, so n minus 1, that is 2 minus 1 is equal to 1. So L can have values 0 and 1. Okay, and S and P will be there. 2S and 2P. If it is 3, n is equal to 3, then 0, 1, 2. Because L is equal to n minus 1. This is how it works. Okay. Oh, you are learning periodic table. That's very nice. Yeah, completed till 36. Oh, that's great. That's very good, Tarun. Keep it up. Next, azimuthal quantum number. We are still discussing that. See here, azimuthal quantum number. It is represented as by the letter L, small l. Okay. And L is equal to n minus 1. It tells us the relative energies of the various subshells. And the energies of the different subshells present within the same principal shell are found to be in order. S has the least energy. Next P, D and F. S, P, D, F. Okay. Yeah, Basaraj sir is quite busy in NEET channel because NEET exam is around the corner. That's why. Yeah. So L is equal to 0. Subshell is yes. The shape of the subshell will be spherical. For P subshell, it is dumbbell shaped. D, double dumbbell shaped. And F, it is a complex shape. Okay, it's a very complex shape for subshell F. And F has the highest energy amongst SPDF. So azimuthal quantum number. See there, F shell, subshell is quite difficult to draw. Okay, so you can remember till D subshell. P subshell, dumbbell shape. D, double dumbbell. S, simple spherical. Okay. So it tells us the angular momentum of the electron present in any subshell. Angular momentum of electron is equal to root of L of 1 plus L into h by 2 pi. H is the Planck's constant. Okay, H is the Planck's constant. Next we have magnetic quantum number, third one. So magnetic quantum number gives the number of permitted orientations of subshell. What is the orientation of subshell? This will be given by magnetic quantum number. For example, for the given value of L, the possible values of M range from minus L to plus L, which means that if L is equal to 2, so it could be minus 2, minus 1, 0, plus 1 and plus 2. Okay, each value of M corresponds to one atomic orbital. Orbital is the probability of the space where the probability of finding the electron is more. Alright. Yes. So subshell. If the subshell is yes, the value of M is equal to 0. Number of orbitals present is just 1. If subshell is P, L is equal to L is equal to 1 means subshell P will be there. The value of M will be minus 1, 0 plus 1. 3 orbitals are present. For D, 5 orbitals. For F, it is 7 orbital. Okay. Next, spin quantum number. It has been observed that the electron in an atom is not only revolving around the nucleus, but it is also spinning about its own axis. So just like Earth or any other planet, it is going to revolve around itself and then revolve around the sun. Right? Just like that, the electron also does the same thing. It revolves around itself, it spins, and it is going to revolve around the nucleus. Okay, so it is given by spin quantum number. Hi Junil, long time no see. Hi Sonali, welcome back. Junil also welcome back. It's been some time since you guys were in this channel, came to the class. Be regular guys, we are conducting foundation course. Okay. Yeah, it has been observed that the electron in an atom is not only revolving around the nucleus but is also spinning about its own axis. Tarun, why? It's only 7:30. Stay back, no? There is a match today? I don't think there is a match today. I don't know. I don't follow cricket anyway. Yeah, clockwise direction or anti-clockwise direction. Okay, so spin quantum number can have only two values, either plus half or minus half. So the two spins of the electron can also be represented by arrows pointing in the opposite direction, like this. Okay, how is this? Like this. So for anti-clockwise it is minus half, for clockwise it is plus half. Okay. What about Lalit? I don't know about Lalit and Krishu, Tarun. No idea. They haven't been to the live classes in recent times, I guess. They're enjoying summer holidays, probably. Yeah, the value of spin quantum number is independent of the values of other three quantum numbers. It doesn't depend on other three quantum numbers. But for magnetic quantum number, azimuthal quantum number, it depends on the principal quantum number. Okay. Next, which of the following set of quantum numbers is not valid? N is equal to 5, L is equal to 2, M is equal to 0, S is equal to half. So you don't have to consider this spin quantum number because it is independent of the other quantum numbers. But what about others? Give me the answer. N is equal to 5. So L will be N minus 5. Right? So it can be 4. Give me the answer. It's option B. Okay, N is equal to 1, L is equal to 2, M is equal to 0, S is equal to half. Why is this not possible? Yes, because L is equal to N minus 1. Here, N is equal to 0, N is equal to 1, which means that it will become 0. L cannot be 0. I mean, L can be 0, but here it is mentioned 2. So this is wrong. Okay, all the others are right here. It is possible. They are valid. Alright. The principal quantum number of an atom is related to the dash. Orbital angular momentum, orientation of the orbital in space, spin angular momentum, size of the orbit. It's not going to depend on the size of the orbit. We can eliminate that. Give me the answer. Sunali Suhas sir already took the live and he went. He's not in the office. It is size of the orbit. Okay. So yes. Principal quantum number of an atom tells about the size of the orbit. The distance from nucleus to the orbit. Okay. Next, what is the correct orbital designation of an electron with a quantum number? N is equal to 4, L is equal to 3, M is equal to minus 2 and S is equal to half. Orbital designation. N is equal to 4, L is equal to 3. L is equal to 3 means it is 4f. Okay. N represents the fourth orbit. 3 represents the F shell. Okay. 1 represents S. Okay. 2 represents P. 3 represents SP. Okay. Small functioning. Just give me a second. So N4 represents fourth orbit. Okay. 3 represents F subshell and M is equal to minus 2. It represents the orientation of F orbital. S represents the direction of the spin of the electron. So the orbital is 4f. Let's go back and see. Look at this. L is equal to 0, S. So L is equal to 1 represents P subshell, 2 D subshell, 3 F subshell. Okay. Next, Pauli's exclusion and Aufbau principle and Hund's rule. Let's discuss that. So Aufbau principle. This principle states that the electrons are added one by one to the various orbitals in order of their increasing energy, starting with the orbital of lower energy. Until and unless the orbital of the lower energy is not filled up, the electrons cannot be filled to the next orbital. Okay, so it depends on the energy. So the lower energy orbital should be filled first in order to in order for higher energy orbitals to be filled. The increasing order of energy of various orbital is 1s, 2s, 2p, 3s. This is very, very, very important. In order to write the electronic configuration, this is very, very important. Okay. So until now, until in your till your high school 9th and 10th, so electronic configuration used to write like this: 2, 8, 2, right? But you cannot be writing like that. Okay. So this is the pattern that you should follow. The increasing order of energy of various orbital. So this is the easier way. Okay. Start from the top. The direction of the arrow gives the order of filling of orbitals, and this quite varies sometimes when it is half filled or completely filled. This is something that you will be learning in 11th and 12th standard. How is it going to vary and all? Okay, so write like this: 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s. Then we have p, okay, and p subshell, d subshell, and f subshell. All right. So in the ground state of an atom or ion, electrons are filled in orbitals in the increasing order of orbitals energy. N plus 1 rule is there. If n plus 1 are different, so greater the n plus L value, not L, 1, it is L. Greater the n plus L value, greater the energy of the orbital. Greater the n value, greater is the energy of the orbital. If n plus L are same. Okay, this is nothing but Aufbau principle. What about Pauli's exclusion principle? I'm great. Thank you for asking. Yeah, Munwar. How are you? So, no two electrons in an atom can have the same set of all 4 quantum numbers. For every electron, it differs. Even though there are 2 electrons in an atom, just 2 electrons like helium. Okay. But both of them cannot have all the 4 quantum numbers same. Spin quantum number, magnetic quantum number, no, it cannot be same. In an atom, if 3 quantum numbers are same, then 4th quantum number must be different. If n, L and ml are same, then ms, that is spin quantum number, will be different, definitely. Okay, an orbital cannot have more than 2 electrons, but the spin of electrons is same, orbital must be different. Okay, so this cannot be the right one, because for this all the quantum numbers will be equal. Okay, yeah, it can be equal, which n, L and ml, it can be equal, but the last quantum number, that is spin quantum number, will be different. So we'll be representing like this. This is nothing but electron, spin of the electron. Okay, so electrons will not pair until all the degenerate orbitals are singly filled. So this is not the case. Okay, degenerate means distinct or same energy orbitals are singly filled first, only then pairing is going to happen. So this is highly reasonable if we consider the electron-electron repulsion. Hence, electrons obey Hund's rule as it results in lower energy state and hence more stability. Okay, so Hund's rule of maximum multiplicity says that electrons will not pair until all the degenerate orbitals are singly filled. Only then pairing is going to happen. The electrons identified by quantum numbers n and L, yes, can be placed in the order of increasing energy. Increasing energy means lowest to highest energy. Which has the lowest energy here? See and give the answer. N is equal to 4, L is equal to 1. N is equal to 4, L is equal to 0. N is equal to 3, L is equal to 2. N is equal to 3, L is equal to 1. As of now, no. We are not taking, we are just taking foundation classes for the competitive exams, but not the actual classes. I mean, actual concepts for your competitive exams. It's just the foundation, the basics. What is the answer? Option A is the answer. Okay. See here, according to Bohr principle, greater is the n plus L value, greater will be the energy. Okay. So you have to count. Only then you will know the answer. Okay. For same n plus L value, greater the value of n will lead to higher energy. For example, here and here, the n plus L value is equal. So which will have the highest energy? This will have the highest energy. Because n value is more here. Here it is 4 and in the third one it is 3. That's why. Okay, so it is fourth one has the lowest energy because it is 3 and it is 4 here. N plus L value is equal but n value is different. That's why. Okay. Next, the order of filling of electrons in the orbitals of an atom will be dash. What is the order? Remember that 1s, 2s. See that and give the answer. You can go back and see. Come on guys, what is the answer? What will be the answer? Option B. Okay. See here. Option B is the right answer. 4s, 3d, 4p, 5s and 4d. Moving on. Yeah, option B, Vignesh. It is option B. Okay. In a given atom, no two electrons can have the same values for all the 4 quantum numbers. This is called dash. Which rule is this? Hund's rule talks about, the spin. Exclusion principle. Uncertainty principle. What is this uncertainty principle? Spontaneously, simultaneously we can calculate. We cannot calculate the position and the momentum of an moving, electron. Okay, that is uncertainty principle. What about Bohr principle and Pauli's exclusion? It is Pauli's exclusion. Okay. So Pauli's exclusion principle states that in a given atom, no two electrons can have the same values for all the 4 quantum numbers. Even if all the first 3 quantum numbers are equal, the number, then the spin will be different. The spin quantum number will be different. Okay, it's going to be plus half to one of the electrons and minus half to another. So let's summarize now. We have discussed about shape of s orbital, shape of p orbital and shape of d orbital. Okay, so we have previous year questions and we have important questions from this chapter. All right, so we will be discussing that in during week quiz. Okay, we'll be discussing that during week quiz. Now let's discuss about filling of orbitals in an atom, how to write electronic configuration and valency of elements. So what is the difference between orbit and orbital? An orbit is a well-defined circular path around the nucleus in which the electrons revolve. But orbital is the space around the nucleus within which the probability of finding an electron is maximum. We do not know for sure where the electron is exactly placed or positioned. Orbit, it represents the planar motion of an electron around the nucleus. It represents the 3-dimensional motion. Orbital represents the 3-dimensional motion. Okay. Next, the maximum number of electrons in any orbit is given by 2n square. The maximum number of electrons in any orbit is given by 2n square, where n is, what is n? It is the number of the energy levels. Okay, for k n is equal to 1, for L n is equal to 2. And all orbits are circular in shape. On the other hand, we have orbital. The maximum number of electrons present in any orbital is 2. and different orbitals have different shapes. For example, S, it has spherical shape, P, dumbbell shape, D, double dumbbell shape, F, it has a complex shape. So filling of orbitals in an atom contains a large number of orbitals, and these orbitals are distinguished from one another on the basis of their shape, size, orientation in space. Okay, so shape is determined by L, size is determined by N, and the orientation is determined by M. These characteristics of an orbital are expressed by a set of numbers known as quantum numbers. If we know the quantum numbers, we can easily identify the shape, size and orientation of the respective electron. So quantum numbers are like the address to electron for a particular electron. The electrons are filled in orbitals of an atom on the basis of three principles: of Bohr principle, Pauli's exclusion principle and Hund's rule of maximum multiplicity. So according to Bohr, in the ground state of an atom or ion, electrons are filled in orbitals in the increasing order of orbitals energy. So we should know n value and L value in order to fill up the electrons in respective orbitals. Okay, n value should be known, L value should be known. If n plus L value are different, then greater the n plus L value, greater is the energy. If n plus L value is same, then we are going to consider the n value. Greater the value of the n, greater is the energy of the orbital. Okay, distinguished means differentiating, Vignesh. Distinguish means differentiation, difference. So according to Pauli's principle, an orbital cannot have more than 2 electrons, but the spin of electrons in the same orbital must be different. Okay, spin should be different. Okay, according to Hund, electron will not pair up until all the degenerate orbitals are singly filled. Hund's rule of maximum multiplicity says that so only from the lower energy, lower energy orbital to higher energy orbital, the electrons are going to fill up. Okay, everything is filled up singly. Only then they are going to pair up. They are going to pair up. So shape of d orbital is dash, spherical, dumbbell, double dumbbell, none of these. What's the answer? D orbital. S is spherical. S is spherical. What about others? Dumbbell, P. Double dumbbell, D. Okay. It is option C answer. Very good, Vignesh. Absolutely right. The shape of the orbital is determined by a quantum number which is represented by a symbol dash. L, N, M, S. The shape of the orbital is determined by a quantum number which is represented by a symbol dash, which determines the shape L, N, M, S. It is L. Okay. The shape of the orbital is determined by the azimuthal quantum number. Double dumbbell, spherical, that is given by the value of L. Okay. Option A is the right answer. Very good, Vignesh. Next, electronic configuration. What is electronic configuration? It is nothing but the arrangement of electrons. Okay. The arrangement of electrons in the various energy shells or levels of an atom of the element is known as electronic configuration. So, electronic configuration is based on certain rules given by Bohr-Bury scheme. Okay, the maximum number of electrons which can be accommodated in any energy shell of atom is given by 2n square. And in energy shells, we have subshells as well, SPDF. The outermost shell of an atom cannot accommodate more than 8 electrons. Even it has capacity to accommodate more electrons. Okay, the maximum number of electrons can be 8 in the outermost shell of an atom. The electrons in an atom do not occupy a new shell unless all the inner shells are completely filled. Okay, so Hund's rule of maximum multiplicity almost same. Okay, only if the K shell is completely filled, we can go to L shell. After we fill up K and L, we can go to M. Okay, so we know that M shell can accommodate up to 18 electrons, but in case of elements such as potassium, iron, so N shell has started to fill even before M shell is complete with 18 electrons. Okay, so there are always exceptions. It's about stability of the respective element. Alright, cobalt, zinc. So 0 shell has started to fill, O shell. not 0. O shell has started to fill even before N shell is complete with 32 electrons. Okay. So K, L, M, N, O. So the list goes on. Due to this abnormal behavior, a different way of writing electronic configuration was introduced. Okay. So distribution of electrons in different orbitals of an atom is known as electronic configuration. We already know this. So how do we write electronic configuration? Previously we need to follow Bohr-Bury scheme, but that was not sufficient in order to satisfy how to write the electronic configuration for higher elements, like the elements with greater atomic number. So we make use of Pauli's exclusion principle. We inculcate Bohr rule and Hund's rule. Okay. So we make use of NSX and NPY notation and orbital diagram. So principal quantum number before respective subshell. So subshell is indicated by the respective letter symbol. Number of electron in subshell. It will be used as the superscript. On the top of the letter, you are going to write the number. For carbon, Z is equal to 6. That is atomic number is equal to 6. How do we write that? 1s2, 2s2, 2p6. 1s2, 2s2, 2p6. Okay. So what are we following? This one. So we wrote this, right? 1s2, 1s, 2s, 3s, 4s, 2p, 3p. We followed this, right? So this needs to be remembered. This is very, very important. Take your own time, okay? But you have to be very thorough with this. And orbitals of subshell. So we'll use boxes, okay? So electron with clockwise spin will make use of the upward arrow. For anti-clockwise, we'll make use of the downward arrow. Okay, so in chemical equations, what does it mean? It means that gas is evolved. Okay, it means that precipitate is formed, but not in case of physical chemistry. Okay, in physical chemistry, as in while we are writing electronic configuration, these have different meaning. Upward arrow means clockwise spin, downward arrow anti-clockwise. Okay, the electrons in the completely filled shells are known as core electrons. And the electrons that are added to the electronic shell with the highest principal quantum number are called valence electron. So valence electron are the electrons that are at the outermost shell of an atom. Okay. For hydrogen, it is 1s1. Helium 1s2. Lithium 1s2, 2s1. So in lithium, what is 1s2? It is a core electron. This is a completely filled shell. Okay. So this is the valence electron. 2s1 is the valence electron. For example, in case of sodium, there are 10 electrons, okay, that are the core electrons, because all of them are completely filled. That's why, see, completely filled. This one is not completely filled. There is only one electron. It is not paired. This is the valence electron. In case of silicon, see the silicon here. So all of them are completely filled. Okay, not the P. It's not completely filled. Okay. So in case of silicon, 10 are core electrons and 4 are valence electron. 10 are core electrons and 4 are valence electrons. Okay. Next, see here, electronic configuration. This is how we write. In your high school, this is not how you wrote. Okay. You just write, I'll show you. We would just write 2,2 for beryllium, boron 2,3. Okay, 2,4. But now we are not going to write like that. Okay. Yes. Take this down. This is very important. Neon is a noble gas. So completely filled, shells and subshells can be seen here. In case of ions, the electrons are removed first from the valence shell. Only then we are going to go to the lower energy shells. Okay. So for Fe, this is the electronic configuration. Argon, the electronic configuration argon followed by 4s2, 3d6. Fe plus, first will be removing from here. Okay. So for Fe2 plus, we are going to have to remove 2 electrons, right? We'll be removing from here. Okay. Only then we will be removing from the D shell. Okay. D subshell, I mean, not the shell. Yeah. Next configuration like P3, P6, D5, D10, F7, F14 are found to be extra stable. This is something that you will be studying in D and F block elements. You will study this in D and F block elements. Okay. So these are half filled and completely filled. So P can accommodate maximum of 6 electron. If it is half filled, it is very stable. If it is completely filled, it's extremely stable. Similarly, so D can accommodate 10 electrons total. If it is completely filled, this is extremely stable. Even D5 is also extremely stable. F subshell can accommodate 14 electrons. Okay, this is fully filled, this is very stable. Even F7, which is half filled, this is also stable. Okay, so yes, nitrogen has electronic configuration 1s2, 2s2, 2p1, 2p, yes, 2p3 it is, and not 1s2, 2s2, 2p2, 2py1, 2pz0, which is determined by dash. The lower energy must be singly filled, only then pairing up occurs. What is it? Hund's rule. Pairing of electrons in degenerate orbitals can't take place before all the orbitals have single electron each, as guided by Hund's rule. Okay. Next, which of the following configuration is the most stable? Which is most stable? Either half filled or completely filled will be more stable. Which is half filled or completely filled here? Yes. 1s2, 2s2, 2p6, 1s2, 2s2, 2p1, 1s2, 2s2, 2p4, 1s2, 2s1. It is option A. Okay. So 1s2, 2s2, 2p6 is completely filled electronic configuration because P can accommodate 6 electrons. It's completely filled. Here it's just 1. It is neither half filled or completely filled. Even this one, neither half or completely. This is half filled, but this is completely filled. Completely filled will be more stable. Okay. Next, identify the correct electronic configuration for aluminium. In order to write the electronic configuration, you need to follow certain principles and rules. Okay, and you need to know the atomic number of the respective element. What is the correct one? This is your homework question. Okay. Next, valency of elements. So valency, this is the electron present in the outermost orbit of an atom, are called valence electrons. So if we study about valency of elements, so valency is these are called valence electrons, the outermost orbit. So how many electrons are present in that, it is valence electrons. But what is valency? Valency is the combining capacity. So this is something that you have studied in 9th standard, CBSE prescribed syllabus. Okay, it is the combining capacity. So combining capacity, or the tendency of an atom or element to donate or accept or share electrons. Okay, that is valency. When atoms of an element combine with another to form a compound, they do so in fixed numbers depending upon the capacity of the atoms to form bonds. If it is covalent bond, what is going to happen? Sharing of electrons is going to happen. If it is the ionic bond, the transfer of electrons is going to happen. Okay, the capacity of an atom of an element to form chemical bonds is known as its valency. For homework question, it is C. You already gave the answer. It is option A. Okay, the atomic number of aluminium is 13. Good try, Vignesh, but it is option A. Okay, it's not option C. It is 1s2, 2s2, 2p6, 3s2, 3p1. Only after 3p1 we'll have 4p. Okay, follow that zigzag pattern there. So the valence of an element is decided by the number of valence electrons in its atom. For example, for the elements with the valence number of electrons greater than 8, then it is going to be 8 minus the number of valence electrons. If it is less than 4, then it is going to be valence is equal to valence number of electrons. Okay. Yes, number of valence electrons. So valence electrons is equal to 7. Then valency will be 1, which means that valency of non-metal is equal to 8 minus number of valence electrons in an atom. Okay, you can see here sodium is a metal. For metals, valency is equal to valence number of electrons. Valence number of electrons. Okay, yes. Which of the following do not have the same number of valence electrons? hydrogen, lithium, sodium, potassium, boron, aluminium, nitrogen, phosphorus, helium, magnesium, beryllium, cadmium, calcium, cadmium is Cd, sorry, oxygen, sulfur, selenium. The elements belonging to the same group will have the same number of valence electrons. I'll write here. This is something that you will be studying in periodic, periodic classification of elements. Okay, how valency or atomic weight, not atomic weight, but radii is going to change. Yes, elements in the same group will have belonging to the same group will have same number of valence electrons. Number of valence electrons or valency. Okay. Yes. Option B is the right answer. Boron 2, 3. So yes, 3 valence electrons are 3 here. For aluminium 3, but nitrogen has 5. Nitrogen is a non-metal. Okay. Phosphorus 2, 8, 5. Phosphorus is also a non-metal. So valency is not going to be the same. Or valence electrons. Next. How many valence electrons are in an atom? P. Valence electrons are different. Valency is different. Valency of phosphorus will be 8 minus 5, which is equal to 3. Okay. Here also, see here, valency is equal. Valency of all these elements are 3 only. Okay, they are asking about number of valence electrons. It is different. Valence electrons are different. Valency is different. Okay. Yes. The valency of aluminium is dash. How many? 2, 5, 3, 4. What is the combining capacity of aluminium? It's a metal. So, valence number of electrons is equal to valency. It is 3. Okay. So, let's summarize now. So, we discussed about electronic configuration. We need to inculcate all these rules. Pauli's exclusion principle, Aufbau principle and Hund's rule. Okay. And what is valency? We discussed that. That's it. So, the problems for practice and previous year questions we will be discussing during week quiz. Okay. So, I will be giving you the week quiz maybe on Saturday. Okay. So, you revise this chapter thoroughly. Okay. You can answer and you can, see the competition. Okay. Where you stand in your preparation and everything. Alright. I'll see you all in the next session. That is tomorrow. Thank you so much, guys. And please do subscribe to the channel and turn on the notification button. I'll see you all in the next class, that is tomorrow. Okay. And whichever homework is there, if you have taken notes, please revise it once again. Alright. Bye-bye. All of you have a good night. Ta-ta. Gokul, the next class is tomorrow. Okay. We'll discuss Is Matter Around Us Pure Part 1 tomorrow. Cool? Bye-bye. Ta-ta.